Today we're going to talk about polar coordinates again and their relationship to what you have known and loved for years, the rectangular coordinate system. So let's picture we have some point P here. There's now two systems for identifying this point's location. There's the old-fashioned x, y. That is the rectangular coordinate system, where you say how far left and right and how far up and down, and you get an x and y coordinate. Our new system we have a distance from the origin, which is called r, and then we have an angle theta measured around the pole. So this point can also be r and theta. So our rectangular coordinates, also called Cartesian coordinates, are x and y. The polar will be an r and a theta. So today's lesson, we're going to be going back and forth between the two systems. And first we're going to do this with coordinates. So we're going to begin by going from polar to rectangular. So we're going to start with an r and a theta. Okay, now think back to vectors. We had a magnitude and a direction, and we turned it into its components. Same thing here. I have an r and a theta, and I want to get x and I want to get y. Well, x, cosine of theta, is going to be x over r. So my x is going to be r cosine theta, just like with vectors. My y is going to be r sine theta. And we end up with an x and y coordinate. So let's convert a coordinate. So we're going to convert to rectangular. So we have an r and a theta, and we want an x and a y. So x is going to equal r cosine theta. Y is going to equal r sine theta, always. So in my example, x is going to be 12 cosine 30. We'll use our unit circle to evaluate this part. Cosine of 30 is root 3 over 2. So my x coordinate is going to be 6 root 3. Y will be 12 sine 30, which will be 12 times 1/2. So my y coordinate is 6. So my coordinates are 6 root 3 and 6. Now I want you guys to try the point 2, 3 pi over 4. Okay, when you plug this in, my x is going to be 2 cosine 3 pi over 4. So we get 2 times a negative root 2 over 2, which is a negative root 2. Y is 2 sine 3 pi over 4. So that's going to be 2 times a positive root 2 over 2. So we get root 2, so this one is negative root 2, root 2. Okay, now we're going to go the other direction. And you can think again about how we did this on for vectors. So here, if I have this, we have an x and a y, and we want to get the r and the theta. Well, the r is easy, because we know x squared plus y squared is going to equal r squared. So my r is just going to equal the square root of x squared plus y squared. And r can be positive or negative, but for the sake of ease, just use the positive one. For our theta, we know that the tangent of theta is going to equal y over x. So theta will be the tangent inverse of y over x. I'm going to look at this in two different cases. Okay, the first case is that tangent inverse of y over x is on your unit circle. So I suggest you fill in those values on your unit circle. If that's the case, then your xy, my r, is just going to be the square root of x squared plus y squared. Theta will be the tangent inverse of y over x in the correct quadrant. Our result will be our r and theta. Alright, so let's convert to polar, and we're going to take the point negative 2, 2. My r will be just the square root of 2 squared plus 2 squared. So 4 plus 4 would be 8. I don't care about the negative because I'm just squaring it. And you can simplify this to 2 root 2 if you want, or not. Next, my theta will be the tangent inverse of 2 over negative 2. So we're looking for the tangent inverse of negative 1. If this is on the unit circle, that's what we're going to use, and negative 1 is on the unit circle. So our values for tangent are 0, root 3 over 3, 1, root 3. So we're looking for the negative ones, which is going to occur here and here. Well, is it going to be 7 pi over 4 or 3 pi over 4? If we were to graph this point, negative 2, 2, we're in the second quadrant. So my theta is going to be 3 pi over 4 to match that. So this is the point, root 8, 3 pi over 4, or if you wanted, you could do 135. Alright, so I want you guys to try negative 4 and negative 4 root 3, converting that to polar. R will be the square root of 4 squared plus 4 root 3 squared. So that's the square root of 16, and then 16 times 3, 48. So square root of 64, which is 8. Theta will be the tangent inverse of negative 4 root 3 over negative 4. So that's the tangent inverse of just positive root 3, which is going to occur at 2 locations on the unit circle, in the first quadrant and the third quadrant. Well, we're in quadrant 3, so the corresponding correct angle is 4 pi over 3. So this is the point 8, 4 pi over 3. Okay, we're going to do one more, and I'm not really going to do any calculations. I'm just going to draw this. So -3, 0, -3 would be this point here. R is the distance from the pole, so that's going to be 3. And then my theta, well, what's the angle if we're down here? Think about this as being the polar plane. This is going to be 3 pi over 2. So if it's on one of the axes, we just need to find which one corresponds. The second case is if tangent inverse of y over x is not on the unit circle. So it's still the same calculations. X, y, my r is still going to be square root of x squared plus y squared. That's not going to change. The issue is going to be with the tangent inverse. If it's not on the unit circle, that means we're using the calculator. And when we use the tangent inverse, it's always going to give me the inverse function values. So for tangent, that's going to give me an answer between -pi/2 and pi/2. So that's fine, as long as our angle is actually in one of those quadrants. Okay, if it's in quadrant 1 or quadrant 4, we're fine. If it's not, though, we're still going to have to depend on the calculator. And we're going to have to add pi or 180 to get to the second quadrant or the third quadrant. Our results will then be our r and theta. So let's do an example of this. So we've got the point -4, 3. So my r will be the square root of 4 squared plus 3 squared. So that's 16 plus 9. We're getting r of 5. Theta is the tangent inverse of 3 over -4. 3 over -4 is not on the unit circle, so we need to use our calculator. So if I do, and I'm going to do this in degrees just so it's really clear what's happening. Okay, so let's say I do this. Okay, we get an angle of -36.8 degrees. So -38 would be down here. The point -4, 3 is not there. So we are going to have to add 180 to get the correct answer. So if I add 180, we get 143. Now just think about this, geometrically. Does that angle being 143 make sense if this is 0? Yeah, that's a reasonable answer. So this is going to be the point 5, 143.1 degrees. Now most of the problems you will do will be unit circle problems. But just in case, this is how you're going to handle if it's not on the unit circle. Now we're going to convert equations. And we're going to start with going from rectangular to polar, because that's fairly straightforward. We're just going to replace the x and the y. We'll replace x with our cosine theta, and we'll replace y with our sine theta. Okay, so we're going to identify the graph of each polar equation or rectangular equation I give you, then write it in polar form, and then we're going to graph it. So we're going to start with x squared plus y squared equals 49. So x is our cosine theta. Y is our sine theta. So this becomes r squared cosine squared plus r squared sine squared. I'm going to pull out the r squared. When we're using polar, if we can, we want to solve for r. Well, what's sine squared plus cosine squared? That's just 1, so this is just r squared equals 49, which means r equals 7, which makes sense, because what type of graph is this? This is a circle whose center is 0, 0, and the radius is 7. Well, this would be a circle centered at the origin with a radius of 7. So I'm actually going to add, we could have actually jumped to this point right here, because x squared plus y squared does equal r squared. So I'm going to add that up here. But you can get there with just these ones as well. But you could jump from this to this, because we know in our little triangle, x squared plus y squared equals r squared. For our graph, we'll just do a circle at 7. And you can do this on the polar graph or rectangular. All right, so our next one, we're going to have x plus 2 squared plus y squared equals 4. So this is again a circle. The center is going to be at -2, 0, and the radius will be 2. All right, so before I convert it, I'm going to FOIL this. So we're going to have x squared plus 4x plus 4 plus y squared. Okay, then convert. So the x squared plus the y squared, I can replace with r squared. Then I have this 4x is going to be replaced with r cosine theta. Okay, plus the 4 equals 4. We're going to solve for r here. First step, I'm just going to subtract 4 from both sides. So r squared plus 4r cosine theta equals 0. I'm going to subtract this bit over. So r squared equals -4r cosine theta. Then I'm going to divide both sides by r. So there is my polar equation. So for our graph, we're centered at -2, 0, and a radius of 2. Okay, so our last one of these is going to be y equals -4. So what type of graph is this? Horizontal line at -4. So I can go ahead and start with the graph and then we'll convert. So that's -4. So there's my line. So what does a horizontal line look like in polar form? Well, we're just going to replace y with r sine theta and then solve for r. So we'll divide by sine. So this is going to be -4 cosecant theta. So this is what a horizontal line looks like in polar form. Now we're going to go the other direction, from polar to rectangular. Now we know from going from polar to rectangular, we use the Pythagorean theorem and we use tangent inverse. We want to avoid that with the equations. So what we're going to do is try to manipulate our formula to get 3 things. If I can get an r cosine theta, then I can replace that with x. If I can get an r sine theta, then I can replace that with y. And if I can get an r squared, then I can replace that with x squared plus y squared. So now we'll do some examples. So our first one in polar that we're going to convert to rectangular is r equals 5. Now this is going to be the reverse of what we did on the other side. We know what this looks like. It's going to be a circle with a radius of 5. Okay, I can easily get this by squaring both sides. And then I can replace this with x squared plus y squared. Here's our next one. R equals 2 secant of theta. So first I'm going to use my identity. Secant is 1 over cosine. So then I can multiply by cosine. So our cosine theta equals 2, which means x equals 2. So this would be a vertical line. Okay, r equals 2 sine theta. Okay, well, I could square it to get an r squared, then that gives me a sine squared, which isn't very helpful. But what I can do is multiply both sides of this equation by r. So then r squared is x squared plus y squared. My r sine theta is y. Okay. Now I'm okay with you leaving it like this. This is the equation for a circle, and you could get the center and the radius by completing the square, or we can just leave it like this. For my last one, we're going to handle this a little bit differently. Theta equals pi over 3. If I were to graph that on the polar plane, that's just going to be a line through pi over 3. This angle is pi over 3. Okay, so we know the equation for a line is y equals mx plus b. So we need to find the slope and the y-intercept. Well, the y-intercept is just 0. So we just need to find the slope. And to find the slope, we need a point on the line. Well, we happen to know a point that's exactly 1 unit out on this. 1/2 root 3 over 2. Okay, well, slope is going to be the rise over the run. So it's rising root 3 over 2 up, and it's running 1/2, which is really just root 3, which is the tangent at that point. So this equation would just be y equals root 3 x plus 0, because that's our y-intercept. So that's how we convert between the two coordinate systems, polar and rectangular.